Welcome back to geometry. This is our third part of our first section, finding areas of basic figures. And we are going to be given coordinates of the figure, and then from there we want to find perimeter and we want to find the area. So the first thing we want to do when we're given these coordinates is we want to plot them. So here, A is at negative 8, 6. Negative 8 goes off my graph a little bit. That's fine. We can still put it on there. B is at negative 5, 8. So again, B goes off of this graph just a little bit, but that's fine. C is at negative 2, 6. And D is at negative 5, 0. So here is our diagram. Okay. So the first thing we want to do here is we are going to want to find the perimeter. Well, how can we find the perimeter of this? We can find the perimeter by finding the distance of our four sides and adding those four distances up. So to find the distance of the four sides, we are going to use our distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Or, remember, you can always view this as how much do your x's change and square that, plus how much do your y's change and square that. So here, if I want to find the distance from A to B, from A to B, my x's change from negative 8 to negative 5, so they change 3, so 3 squared. My y's change from 6 to 8, so that's 2, so plus 2 squared. 3 squared is 9, 2 squared is 4, so the square root from A to B is, or the distance from A to B is the square root of 13. Repeat the process with the other side. So now from B to C. So from B, negative 5 to negative 2 changes 3, so 3 squared. 8 to 6 changes 2, so 2 squared. Look, that's exactly the same as A to B, so this is the square root of 13. Distance from C to D. Negative 2 to negative 5 changes 3, so that's 3 squared. 6 to 0 changes 6, so that's 6 squared. 3 squared is 9. 6 squared is 36. 9 plus 36 is the square root of 45. And then the distance from A to D. Negative 8 to negative 5 changes 3, so the square root of 3 squared. And 6 to 0 changes 6, plus 6 squared. It's identical to the previous one, so square root of 45. Well, the square root of 13 is about 3.6. And the square root of 45 is about 6.7. So if we want to find the perimeter, we just have to add up all of those values. And when we add up all of those values, we get 20.6 units would be our perimeter. Okay. Now something else you should have noticed when we went to find this is AB and BC, they were congruent to each other, and CD and AD were congruent. When we mark that on our diagram, it's quite clear to see that we have a kite here. So we know to find the area of a kite, we have to take 1/2 diagonal 1 times diagonal 2. Well, here's our diagonal 1, and here's our diagonal 2. Lucky for us, we can count these instead of finding the distance. Because from A to C, it's just horizontal. So this has a change of 1, 2, 3, 4, 5, 6. So our diagonal 1 is 6. From B to D, it has a change of 1, 2, 3, 4, 5, 6, 7, 8. Our diagonal 2 is 8. So the area would be 1/2 6 times 8, or 24 units squared. Now you certainly could have used the distance formula from A to C and from B to D to figure out those distances, but whenever you are vertical or horizontal on your graph, you can always count those. Let's do another example. So first we'll plot these 4 points. Point W is at 3, 0. Point X is at 0, 3. point Y is at negative 3, 0. The point Z is at 0, negative 3. So there is our diagram. It appears as if it is a square, okay? This also appears as if it is a rhombus. But either way, we are going to have to go through and figure it out. So we're going to first find the distances. So change of x squared plus change of y squared, or you can use a full formula if you want to. So from w to x, our x's changed from 3 to 0, 3, so 3 squared, plus our y's changed 3, 3 squared, so 9 plus 9 is the square root of 18. From x to y, from 0 to negative 3, your x's changed 3. From 3 to 0 for your y's changed 3. Same thing as above, so that's also the square root of 18. From y to z, negative 3 to 0, your x's changed 3, so 3 squared. 0 to negative 3, your y's changed 3, so 3 squared. Same thing as we've had before, so square root of 18. And the last side, wz, from 3 to 0, your x's changed 3, so 3 squared. And then from 0 to negative 3, your y's changed 3, so 3 squared, which is also the square root of 18. So there we saw that all 4 of those sides have to be equal, so we do indeed have a rhombus here. So the perimeter would be the square root of 18 times 4. The square root of 18 is about 4.24. So when we times that by 4, our perimeter, we get 16.97, or we would round that to say 17.0 units for the perimeter. The area for this is going to be 1/2 diagonal 1 times diagonal 2. So in this case, your diagonals are here, so we can count them. 1, 2, 3, 4, 5, 6. Diagonal 1 is 6. 1, 2, 3, 4, 5, 6. Diagonal 2 is also 6. So 1/2 6 times 6 is equal to 18 units squared is the area. All right, so there we found the perimeter and the area of that shape. For our last example, we'll have the 3 points L, 2, 6, 2, 6, M, 1, negative 2, and N, negative 4, negative 2. So this forms a triangle. So from here, if we want to find the perimeter, we're going to have to find the distance for all 3 sides. So we'll start with LM. From L to M, the x's from 2 to 1 change 1, so 1 squared, plus the y's from 6 to negative 2 change 8, so 8 squared. 1 squared is 1, 8 squared is 64, so this is the square root of 65. Next side, from M to N, x is changed from 1 to negative 4, which is 5, so 5 squared. Y's changed from negative 2 to negative 2, which is 0, so 0 squared. Well, 5 squared plus 0 squared is just 5 squared, or 25. And we know that the square root of 25 is actually just 5. And then we have to find the distance of our third side. The distance of our third side from L to N. So how much do our x's change from L to N? So 2 to negative 4 changes 6, so 6 squared. Plus 6 to negative 2 is a change of 8, so 8 squared. 6 squared is 36. 8 squared is 64. 36 plus 64 is 100. And the square root of 100 is 10. So if we add these up, the square root of 65 is about 8.06. And if we add that to 5 and 10, we get a perimeter of about 23.1 units. Okay, now to find the area here, we're going to take 1/2 base times height. And remember, our height needs to form the 90-degree angle. So if we look at our diagram, MN would be a good base because it runs horizontal. Okay, so we'll use MN as the base. and MN had a length of 5, so 1/2 times 5. Now to get that height, we have to go from our point L and go horizontal, or go perpendicular 90 degrees. So we'd go vertical down to that base. So here's the vertical, so this would be the height. And that height we can just count. So that height is 1, 2, 3, 4, 5, 6, 7, 8. So our area here is going to be 1/2 times our base of 5 times our height of 8, and 1/2 times 5 times 8 is going to be 20. So the area for this triangle will be 20 units squared.